two diagnostic plots that you can use to evaluate your meta-analysis are the Funnel and the Galbraith plot. And I want to go through these for this particular set of data. The Funnel plot is used to investigate whether there's a problem with publication bias. If you look at the funnel plot, which is actually more like a pyramid, so it's an upside down funnel, what you should see is an even amount of studies that are below the vertical line and above the vertical line. I mean higher numbers and lower numbers in terms of the mean difference. So a positive mean difference in this case means you found an effect. A negative mean difference would mean you haven't found an effect. A zero difference means there's no effect, nothing is happening. The standard error reflects the size of the sample that you've taken. So as you get to bigger studies with bigger sample sizes, your standard error becomes smaller and smaller. So the stronger and the better studies, which have the smallest standard errors, are at the top of your funnel, or the bottom of your funnel if you turn it over. So in this case, Liang is quite a strong study. The weakest of the studies is Ito. Now you have these confidence intervals, or these pseudo confidence intervals, which are marked by the dashed lines. Any papers that fall outside that are unusually different to the average of the rest of the studies, and these are contributing to your heterogeneity of your data. Sahin contributes by being especially negative, and Cerezo, Teles and Vas contribute by being particularly positive. This makes them worth looking at and thinking about what potential methodological problems there are in those studies. So we know there are some with Cerezo, Teles because of dropouts. But apart from that, the funnel plot actually looks good because of this symmetry. There are a similar amount of studies that are on the left-hand side of the line, which is showing less effect than the mean difference, as there are two studies on the right of the line, which is studies which have more effect than the mean difference. This means that negative results are being published as well as positive results, and this is a good reflection on there not being bias in the literature. Now, the Galbraith plot similarly highlights those three papers that were picked out from the funnel plot as being unusual. So the Galbraith plot can be used to pick out outliers which contribute to your heterogeneity problem. And it identifies Vas, Cerezo, Teles and Sahin. So Sahin because it's unusually negative, Vas and Cerezo, Teles because they're both unusually positive. It also puts Liang on the boundary of the confidence interval, and White also falls slightly outside of the confidence interval. And the rest of the papers have a tendency to be a bit below the regression line for the different studies. This is going to happen, they're below the regression line because Vas and Cerezo, Teles are having such a big effect in terms of pulling the line, the gradient of the line, upwards. The shallower the gradient and the closer it is to horizontal, the more you've got a homogeneous set of data. But because of those three different papers, you've got a reasonable slope within the line.